Hey guys, it's Matt, and in this video we'll be going over density. Let's get right into it. Let's begin. Density is the measure of how compact something is. For example, a block of metal will be more dense than a sponge with the same size. That's because the block of metal will have more mass than the sponge in the same volume. Now, the next term we have to know is mass. Mass is a property of an object that defines how much matter the object contains. For example, grams is a measure of mass. Mass also stays constant no matter where the object is. For example, the same 50-gram cookie on Earth will also be 50 grams on the moon, 50 grams on Jupiter, 50 grams on Saturn, anywhere else. Now next, volume is a property of an object that measures how much space an object will take up. For example, liters, gallons, cubic centimeters are all measurements of volume. However, volume, unlike mass, can change with different circumstances. The volume of a gas can either be very big or very small, depending on how big or small the container is. The measure of this is called gas pressure. Probably the most important equation you'll have to know regarding density is this one, which is D equals M over V. All right, so the D stands for density, the M stands for mass, and the V stands for volume. So density is going to equal mass divided by volume. And the most common unit for density is going to be grams over centimeters cubed. So grams is a unit of mass, centimeters cubed is a unit of volume. Let's take a closer look at this equation. So density in this equation is directly proportional to mass. This means that when mass is higher, then density will also be higher if we have the same volume. However, density is inversely proportional to volume. So when volume increases at the same mass, then density is going to decrease, like so. So this trend right here is evident when we take a block of particles. Let's take this block of particles I have right here. So there are 5 particles inside, and let's say each particle represents 1 gram. And let's take this bigger model of the same box with the same 5 particles. In the smaller box, it's going to have a much bigger density than the bigger box because the volume is bigger and the mass is kept the same. Similar to density, we have the concept of concentration. I'm going to move all of this away. Concentration is just how strong a solution is. For example, let's pretend that this orange cylinder right here represents 1 cup of orange juice, and this blue cylinder represents 1 cup of water. Now, if we have a solution of 1 cup of orange juice and 1 cup of water, this is going to be a 50% orange juice solution. But if we have another solution over here, and we have 2 cups of water with 1 cup of orange juice, this is going to be 33% concentration of orange juice. In chemistry, we have a very prevalent measurement for concentration, which is called molarity. I'm not going to go too in-depth about molarity, but the equation is, I'm going to move all this so you guys can see. The equation for molarity is M for molarity equals moles over liters. And this is very similar to our previous density equation, which was just D equals M over V. Moles is simply just a measurement for mass, and liters is a measurement for the volume. Now let's see how we can manipulate the D equals MV equation and how we can see it in problems. So let's say a problem asked for, I'm going to move these cylinders out of the way here. Let's say a question asked for the density. So you have D equals, and they give you the mass and volume, 10 grams, and let's say the volume was 2 centimeters cubed, like so. And so they can ask, what's the density? Well, the density is just simple division, which is 5 grams per centimeter cubed, like so, and this would be your density right here. Another way you can see this equation being used is if you want to solve for mass or volume. Let's say the question asked you for the mass, and they gave you 10 grams per centimeter cubed as density, and we're looking for x grams, and let's say they give you 2 centimeters cubed as the volume. Now the way you're going to find this is simply multiply the denominator and the 10, which is going to be 20. So the answer is x equals 20 grams. And this equation can also be used to find the volume similarly. So let's just say that the question, so we have 2 grams and x centimeters cubed for the volume. Now the way we're going to find this is simply we're going to swap the x centimeters cubed and the 10. So they're going to swap places like so. Move this here. And we know that x is going to equal 1/5 centimeters cubed as the volume. And those are just some ways that we can manipulate the whole equation here. That's all for this video. I hope you guys enjoyed it and learned something. Thanks. Bye.